Today's lesson is on solving equations with rational exponents. First thing we're going to do is define an inverse. An inverse is an opposite operation. So the opposite of addition is subtraction, the opposite of multiplication is division. Those are considered inverses of each other. Just like writing fractional exponents versus writing radicals is considered an inverse, which is why we learned that yesterday. So we're going to use that to solve some equations. When we see fractional exponents, like on number 1, what we want to do is we want to go ahead and rewrite those as a radical. So remember, the 5 that's on the denominator goes on the outside. X to the first goes on the inside equals 3. So in order to get rid of the 5th root of x, what we need to do is raise it to the 5th power on both sides. That's the opposite operation. So we need to raise it to the 5th because that undoes, raising it to the power undoes the radical. It undoes the radical. So the 5th root with the 5th power, these cancel out. So we're left with x to the first, and then 3 to the 5th power, if you type that in your calculator, is 243. And x to the first is the same thing as x, so we are done with that one. Now on number 2, you'll notice that it already is written as a radical. So what we need to do is we need to work from the outside in. So we want to get rid of the 5th root first. So we want to raise both sides to the 5th power, which I know 26 to the 5th power is kind of big. We're actually going to leave it the way it is. So x to the 9th equals 26 to the 5th power because that number is really, really big. And then we want to get rid of the 9th power. And the way we do that is we do the 9th root. So the radicals undo exponents. So we want to do the 9th root of x to the 9th. But if we do it on one side, we need to do it on the other side. So then that's not going to give us a nice pretty answer. So what we want to do is just rewrite it as 26 to the 5/9. And that's the way we're going to leave our pretty answer because otherwise it gives us a yucky decimal. So we want to leave it this way so that we know that we have an exact answer. All right, looking at number 3, we see that we have the 4th root of x equals 5. So we want to get rid of that 4th root by raising both sides to the 4th power. So we get x equals, and we can do 5 to the 4th power. It's 625. And we're done because x is by itself. Now on number 4, we actually need to take care of some exponent rules first. We want to go ahead and distribute this inside. So we're going to get x to the 3/7 equals 21. So then we want to get rid of, or actually rewrite that fractional exponent as the 7th root of x to the 3rd equals 21. Now to get rid of our 7th power, or 7th root, we raise it to the 7th power. So x to the 3rd equals now 21 to the 7th power is a huge number, so we don't really want to type that into the calculator. I mean, you can, but it kind of gets yucky. So what we want to do next is get rid of the 3rd power on the x. So we're going to have to do the cube root on both sides. And so then our final answer is going to be x equals 21 to the 7/3 power. And that's how we solve for x. And yet again, that's a nice, pretty answer. Whereas if you type that in the calculator, you're not going to get a nice, pretty answer. It's really kind of yucky. It's a nasty decimal. Sometimes when we're solving these, they will have more than one term to them. What we need to do is get the x by itself. But in order to do that, we need to add the 2 first. So we have x to the 1/4 equals 5. And now we need to rewrite that as the 4th root of x equals 5. In order to get rid of the 4th root, we raise it to the 4th power. So x is going to equal 625. So we got to get that x by itself first and then rewrite it because it'll help us see more of what's going on. We can't get it by itself or we can't rewrite it until it's by itself. So this one has some more stuff going on with it. It's got more than one thing with it. So remember, in order to solve an equation, we want to get rid of the adding and subtracting first. So we're going to minus the 9 first. So we get 5 times the cube root of 2x equals 20. We want to get rid of that 5. It's multiplying, so we got to do the opposite. We divide by 5. So the cube root of 2x equals 4. Now to get rid of the cube root, we raise both sides. Actually, let me do that on a new line. We raise both sides to the third power. So then those cancel out. So we're left with 2x equals 64. We're almost done here. We need to solve for x. Got to get x by itself. So we want to divide by 2 on both sides. So x is going to equal 32. Here we see that the 3 is being multiplied by everything. So we actually want to get rid of that first. And it's multiplying. So the opposite of multiplying is dividing. So we want to divide by 3 on both sides. X to the 2/3 plus 5 equals 69. Now we need to get rid of that plus 5. So we want to minus 5 on both sides. So x to the 2/3 equals 64. We want to rewrite that. The cube root of x squared equals 64. We want to get rid of that cube root by cubing both sides. (64 to the third power is kind of a large number, so we're going to just leave it. And then we want to do the square root of both sides to get x by itself. So then we get that x equals 64 to the 3/2. It's not a pretty number yet. Again, it's a, actually this one does end up being a pretty number. It ends up being 512. If you type it in your calculator, that's what you'll get. But a lot of times they aren't nice, pretty numbers. All right, looking at this next one, we want to get rid of the adding and subtracting first. So we want to subtract the 5. Then we want to divide by the 3 that's in front because it is multiplying. This is using those equation solving skills. Now we want to rewrite that as the 4th root of x to the 3rd equals 16. So now to get rid of it, we want to raise both sides to the 4th power. You can put it in parentheses. So they cancel out. So we're left with x to the 3rd equals, and you can do 16 to the 4th power, but it's kind of a big number. And then to get rid of that 3rd power, we cube root both sides. So then we're left with x equals 16 to the 4/3, because it is a yucky decimal on that one. Sometimes if you type them in and you get a nice number, then that's fine to use that. But if you get a kind of a yucky decimal, we want to leave the exact answer on there. All right, on this one, we can't do anything other than deal with the radical first. So we want to raise both sides to the 3rd power. And that's because the whole thing is inside the radical. So then when we do that, the radical and the 3rd power cross out. So we're left with x minus 2 equals 64. Then we want to get x by itself. So we want to add 2 to both sides. X equals 66. And that's it. So it looks harder, but it's actually not. It's actually easier because we get to deal with the radical first. In order to solve this one, we do have to get the radical by itself. So in order to do that, we want to add 2 first. So we get radical x plus 2 equals 14. So now to get rid of this radical, remember, if there's nothing written there, it's an index of 2. So that means we need to square both sides. So then when you do 14 squared, you get 196 equals x plus 2, because these canceled out, the squared and the square root. So now we minus 2 on both sides. X equals 194. So while these look a little bit more difficult, they're actually a little bit easier. We are going to omit number 7. We're not going to do it because it does use a skill that we haven't learned yet. So we're going to omit that. We'll come back and solve these later after we learn that skill. All right, last one, number 8. So we have a square root over the entire thing. So then to get rid of that, we have to square both sides. So then when you square both sides, you're left with 3x minus 2 equals 25. And now we solve like normal. Add 2. 3x equals 27. Divide by 3 on both sides. X equals 9. And that's it. And we have finished these notes. You will do the rest of this stuff for practice in class, and you will have some more practice given to you as well. Have a good day, guys.